Welcome back to our course about XML, XSD, WSDL, and JSON. This is Daniel Pinheiro from danielpm1982.com. And now let's start our 3 lectures about XML schema definition, better known as XSD. Just to recap what we've seen so far about XML language, we've seen the general and the specific syntax of XML language itself as the elements, the attribute, the prologue, and also the type setting of each element, as well as the naming of those elements. And we've also seen and worked on some examples about the namespaces, as well as how to refer to XML schemas or XSDs from the XML document instances. So, starting from this lecture, for the next 3 lectures, we'll see everything about how to create XSD or XML schema documents, what are the components, as well as the syntax available for you to design your own XSD documents, and how to test the correctness of both the XSD and the XML instances, as well as the validation of those instances put against the XSD schemas referred by them. So what is XSD? We've seen already a little bit about XSDs, like how to refer to it and the target namespace that it has, so that XML instances can refer to it and use that target namespace to get access to the components that XSD defines and use them at the XML instances. But let's start from 0 here. So, what is XSD? XSD stands for XML schema definition. If you picture an analogy, the XML schema definition or XSD would be like the class of the instances, and the XML document instances would be like the instances of that class, of that schema. And also the namespaces would be like the packages, pretty much as we do when using object-oriented programming languages. So XSD describes and validates the elements, attributes, and data types of XML document instances that refer to it. An XML instance generally, and it is expected to do so, it generally refers to one or more XML schema or XSD document in order, among other things, to validate as well as get access to the elements, attributes, and data types defined at that XML schema. So as we've seen so far, you never define or declare completely, at least, the elements, attributes, and data types inside an XML instance. You'll always refer that instance to a XML schema, and all elements, attributes, and data types that you're gonna use will always come from that schema to which you refer from your XML, as well as from the default namespace from W3C, on which you have all the basic elements and attributes and data types that can be used to create your own data types and attributes and elements at the schema. And we'll see in a lot of examples, starting from this class, how you can create those components and how to design your own XSD schemas to be used on any number of XML instances. So if you look for the history about the evolution of XML, you see that there are basically two types of documents used to write schemas for XML instances. And they are the XSD, which is what we'll see starting from this class on. But we also had an ancient type of schema definition, which is DTD. So we're not talking about DTD on our classes because I really see no advantage on it, but just for comparing these two existing types of documents, and both still are usable for writing schemas. The XSDs are written in XML language. It's not a new language, it's a new type of document, but based on the XML language we've seen so far. So it's nothing new in terms of the language itself or most of its syntax. It's the same syntax we've been using so far. So XSD is written in XML, while DTD is derived from an ancient syntax called SGML, and you can look for some information on that if you want. Another thing is that XSD supports extensibility to the schema, as well as XML also does, but DTD doesn't. XSD supports data types for elements and attributes. DTD doesn't. XSD supports namespaces, as we've seen already, and DTD doesn't support. XSD supports constraints or facets for the values, as we're going to see a lot starting from this class and on. DTD doesn't support constraints or facets. XSD supports definition of the number and the order of children elements. DTD doesn't. And as I've already said, DTD is only used at legacy systems. It's an ancient type of document based on an ancient language. And XSD is the XML schema winner standard, at least so far. Here are two examples of DTD in the next slide of an XSD document, just for you to have a general picture about the very different syntax between them. So this is a DTD, a very simple DTD. It can be much more complex than what's here. I took this example from W3C. And if you want to get into any details about DTDs and its own syntax or about SGML language, you can go to this link down here where you find a good tutorial with everything you need to learn if you want to create, instead of XSD files or documents, DTD documents for your XMLs. Or maybe if you have to give some maintenance on legacy code that once has used DTD instead. Now, here is the XSD example. You don't have to understand any syntax or any organization of the components here. I'm just showing you the general picture about an XSD document, but you can identify that the syntax is pretty similar, as well as the language, to XML document instances, because XSD or XML schema documents are written in XML and not in some other awkward language as DTD. So here you can identify or recognize the namespaces, the prefix, the types. We'll see how to define the simple types and complex types. We'll see how to define the elements and attributes, but the syntax is pretty similar to XML because any XSD is written in XML language. So who maintains it and what are its specifications? As with XML, the maintainer of XSD is also the World Wide Web Consortium, or W3C. And the latest version of XSD is version number 1.1, and the documentation or recommendation is the REC document from April 5th, 2012, the latest version of W3C. So now let's talk about some characteristics of XML schemas or XSD files. XSD, as we've commented already, can be a representation or archetype or blueprint or something similar to a class at object programming languages to all XML document instances you might have. So when you see an XSD document, you have the whole idea about what any XML that refers to that XSD can contain, specifically the elements, the attributes, the ordering and occurrency of those elements, as well as the nesting structure of the elements, and also the accepted types for each element. So you have the whole picture about the possible instances that can be created from that XSD document just by looking at the document and seeing the archetype or the blueprint of the components added. XSD documents can also work as a standard for different groups of people to interchange data among them, specifically data regarding the architecture or the design, similar to what we do in software engineering when we analyze or plan the architecture of a whole system or a part of a system, just by taking into account, for example, the classes diagrams or the sequence diagram of a system we are implementing. So with XSD files, it's a similar case, and you can work along with other people just by looking for the XSD structure. XSD also makes it possible for interchanged data to be validated against. For example, when we see WSDL, which is an XML-based document and which has a part that is an XSD document, you see that we can validate, or more specifically, the APIs can validate the data, whether XML or JSON, just by considering that WSDL file, which in part is a XSD file also. So not only with web services that make use of WSDL, but with any program or API interface that can understand both XSDs as XML or JSON to confront them and validate if the XML is acceptable based on the analysis of the XSD file content. XSD has the purpose of defining the legal building blocks of an XML document. For example, the elements and the attributes that can appear at the XML instances, the number and the order of the child elements, the data types allowed for values of elements, as well as attributes, the default and fixed values for elements and attributes. And XSD also makes it easy to describe a document, define data restrictions, whether restriction on the data type or on further restrictions. XSD also validates the correctness of the data and makes possible the conversion. XSD also turns it easy to edit, parse, manipulate with DOM, and transform with XSLT the code within the XSD itself, similar to what can be done with the XML document instances code with the exact same technologies. So there are some technologies as the DOM, the XSLT, and others that can manipulate and edit, transform and parse the same language used as XML document instances, as well as XML schema documents, which is the XML language itself. So regarding the support for data types now, it's easy to describe allowed data content using XSD documents. It's also easy to validate the correctness of the data. Easy to define data facets or constraints or restrictions, not only with the data types, but with a lot of other types of constraints. It's also easy to define data patterns or data formats, for example, using regular expressions. It's easy to convert from different data types, as we also mentioned before. And as with XML, XSD also has as an important characteristic its extensibility, meaning that one schema can be reused at another schema via import or include. For example, you can import or include 10 XSD documents inside one and only document, and later use that one and only document referred by all your XML document instances. And we'll see an example of it later. But also another thing you can do is to refer to multiple XSD documents from any of your XML document instances, and we will also see some examples of it. Another derivation of extensibility is that you can create your own custom data types based on standard data types that you get access from the default namespace from W3C, for example, which has the basic elements and types you can use to create your own. Now about the security. The data you transfer between servers, for example, that make use of XSD to validate the XML. This data can be described in a way that it's understood by both endpoints or servers when this data is being sent from a sender to a receiver and vice versa. And the validation against an XSD added to the well formation of the XML document itself can catch or reduce the risk of passing data errors on a message, both manually, visually, or more commonly automatically. The APIs themselves, they check if the data you're sending is valid and correct in order to reduce or catch errors of spelling or any other type of incompatibility between the data types or structure. So now let's talk a little bit about the general syntax of XML schemas or XSDs. The first thing on a XSD document, as with XML document instances, is the prologue. And next to the prologue, in any and every XSD document, there will always have to be a root element obtained from the default namespace from W3C, and the name of that root element is always this one, XS colon schema. In all the XSD document content, all the elements, definitions, declarations, all the attributes, declarations, all the tree structure of the elements nested to themselves will always be within the content of this schema element. As with XML instances, XSD documents also import a default namespace from W3C, a different one, but a default one, which is also always the same. And generally the APIs or the IDEs, for example Eclipse, they already set these default namespaces for you. You don't have to memorize that. But the default namespace from W3C is this one, w3.org 2001/XML schema. So from this default namespace from W3C, you get access to all basic and primitive elements and data types and attributes useful for you to create your own components in XSD document. The default W3C namespace is also associated to a prefix for you to use along the XSD document, and by default this prefix is XS, although you can use any other prefix, but by default we'll always use this default prefix XS associated to the default namespace that has the basic elements, attributes and data types from W3C, including the XS column schema elements. XSD files, as we've shown you already, they have one and only target namespace, which is a custom namespace for that document, which is referred to from any instance that refers to that document in order to use the components or the elements, attributes and data types of that element by referring to this target namespace. In this target namespace is the namespace the custom elements, attributes and data types defined at that XSD are associated with, and which can be used by XML instances that refer to that XSD document. And the target namespace can be associated to a custom namespace in order to refer to the elements of the XSD document inside itself. So you need to have a target namespace at the document, but you also, whether at the XML instances or at the XSD document itself, you need to have a custom namespace associated to a custom prefix that will generally use the NPM 1982, but you can use whatever you want in order to link that custom namespace and prefix to the target namespace itself. So in order to have access to the target namespace, you have to create another namespace with the exact same URI and link that to a custom prefix, for example, the NPM 1982, either at an XML instance or at the XSD document itself. And here are 3 examples of XML schemas or XSD files with the prologue, the 3 of them, as well as with the schema element and all the attributes of that schema element that define the default namespace associated to the access prefix, the target namespace. For example, on this one, it's the http://www.danielpm1982.com/animal group. This is the target namespace of this XSD document. Right below, we set a custom namespace with the exact same URI of the target namespace, so that we can have access to that namespace and set this custom namespace to a custom prefix, as usually we're setting it to DanielPM 1982. And right below you have the element form default attribute set as qualified. And later we will see the options for this attribute, element form default. But just in advance, when you set the value as qualified, you're just saying that any XML instance that refers to this XSD document and make use of its components, whether elements, attributes, or data types, must make use also of the namespaces, in this case the target namespace defined at it. But don't worry about it for now. I just want you to have an idea about the schema element and the prologue here, which is like a header for every XSD document we're going to create. Here is another example, also with the prologue, with the schema element, and as attributes of the schema elements, you have the default namespace from W3C associated to the access prefix. You have a target namespace ending with /node. It's a node example. The URI can be anything, as we've been saying, but generally it's some kind of web address, and it ends with some semantic text about that document. So in this case, it's a node XSD document, so we can use the my domain here /node as the URI for the target namespace, which must be exactly the same URI that we set at the custom namespace right below. And this custom namespace, which links to the target namespace, we set to any prefix, any custom prefix you want. In our case, DanielPM 1982. And right below the element form default as qualified. It's always a good practice to set it as qualified, so you can make use of the namespaces and prefix for not inducing any inconsistency or conflict between the elements you're using at your XML document instance. So we always use this element form default as qualified. And here is a third and last example with a prologue with a schema element declaration, and as attributes of that schema, the default W3C namespace associated to the access prefix. As the target namespace, this URI here, ending with a consultation record. In this case, it's an XSD that structures a consultation record. And right below, we set the custom prefix and the custom namespace that links to that target namespace. And lastly, we set the element form default as qualified, as we'll always be doing on our examples. Okay, now let's continue with the general syntax. So an XSD document is composed of simple and generally of complex elements as well. The simple elements may contain only text or data info inside it as its content, and not any nested element nor any attribute. While complex elements, on the other hand, may contain both text, nested elements, as well as attributes. So any element that contains attributes, it's a complex element. Any element that contains eventual nested elements, it's also a complex element. And elements that contain only text and not any element and not any attribute, it's a simple element. And we're going to see at this class and on the next two classes how to declare both simple and complex elements, and how to constrain both the data type as well as some other constraints at the declaration of these elements, as well as at the content of them at an XML document instance. Regarding data types, declarations of and restrictions on data types are done inside the element declarations. We'll also see a lot of it later, as well as other types of restrictions, mainly at complex elements. For example, on the accepted number and sequence of simple elements when nested inside complex elements, the setting of default and fixed or optional or required values, regular expression patterns, enumerations, extensions of elements and types. Also, attributes are declared inside the declaration of each element, and some XSD constraints are done only inside simple elements declarations, mainly the data types, and some content additional constraints on that data types, and others are done only inside complex elements declarations, mainly regarding the nesting or some special constraints about the organization of the elements inside the complex elements. So before we start seeing how to declare the simple and complex elements as well as the attributes and data types, let's first talk about the general design and, as for say, the architecture of the code regarding the components positioning or writing within the XSD code. There are at least 3 ways of writing XSD schema files based on the organization of the declarations of the components, and these 3 ways or design methods can be named as simple method. It's the most simple one, although the one that gains complexity much faster than the others and can end up into a real awkward code. It's the least advisable to use. And we also have the divided method and the name types method. You can choose any one of these 3 types to use, and it's also advisable that you keep one of them as your standard, at least for that project. Avoid complicating the maintenance or readability of the code of the XSD documents you write. So if you choose to use the simple method for writing your XSD documents, the main thing you notice is that all the components are declared at once inside their own global element. For example, you first declare the root element, and inside that root element you declare all other elements at once in a single nesting chain of declarations, so that the only global element you have nested to the schema element is that future root element with everything already declared inside it. So no reuse of declarations is possible, as well as no referring to other previously defined elements or types, because everything is declared inside that future root element, and you can refer to external ones. And also the code gains a lot of code duplication, as you can't reuse the elements or types, as well as the code gets too extensive compared to the other methods. The simple method is the worst in maintenance and readability, and in my opinion, or as my suggestion, you should refrain from use it, and you should use either the divided method or the named types method, which is what I prefer. But you're free to choose any of the 3, and it will work despite which method you choose. So at the divided method, all base elements and attributes are defined first, all as global elements, all nested directly to the schema element, and then the base complex elements are declared and refer to those other elements and attributes using the attribute ref. So you first declare the elements and attributes as global first, then you declare the complex ones referring to the others already declared by using the ref attribute. You don't have to redeclare every repeated element again. You only reference to the one and only elements and attributes you have already declared globally. And finally, after declaring the simple elements and the attributes and all the complex elements that eventually would refer to the other ones, you finally declare the future XML root element, also globally, and also refers to all simple and complex previous elements and attributes you've already declared before by using also the ref attribute. So remember that the ref attribute can be used at element declarations for referring to other elements, or at an attribute declaration for referring to other attributes that are declared globally and that can be referred to from more complex elements, so that you don't have to redeclare everyone every single time you make use of it. You just refer to the elements and attributes already declared globally, how many times you want, in how many complex elements you wish to use them. So it turns the reuse of elements and attributes possible and saves a lot of code compared to the simple methods, for example. And you have a way better maintenance and readability of your XSD document. And if you do decide not to use the simple method, and if you also don't want to use your divided method, there's a third method, which is the one I prefer, which can be called named types method. Instead of declaring a lot of global elements and attributes, you initially declare simple and complex types, not elements. These types are also called classes. And later you reuse those types, those simple and complex types, when declaring the elements inside the complex types, or at the end when declaring the future root elements that you must also declare globally. You mainly declare simple types, then you declare complex types with element declarations inside those complex types, but the types of those elements declared at the complex types are just referred to the simple types you've already declared using the attribute type here and the name of those globally defined types. That's why it's called named types, because here, as you declare the types, both the simple and the complex, in order to be reused later at the element declarations, you must give a name for them. And later, when declaring the elements, either inside the complex types or the root elements at the final, you just refer back to the types you've already declared by using the custom prefix associated to the custom namespace or target namespace, and the name of the type you want to refer to when declaring that element anywhere at your code. So, as with the simple method, at the named types method, generally the root element is the only element directly nested to the schema element, or in other words, it's the only global declared element. All other elements are declared inside the complex types, not globally. So here is an example of the simple method that I advise you not to use. I'm just using it for showing you that, as we've talked, it can end up much more complex than this one here. The more elements nested one inside another and on and on and on, the more complex the code when using the simple method will get. So for example here, you have a ship order XSD document, First, you have the prologue, then you have the schema element declaration. Inside the opening tag of the schema element, you have the attributes defining the namespaces. First, the default namespace from W3C XML schema associated to the access prefix. Then you have the setting of the target namespace, which is this one that ends with ship order simple method or any URI you want. Later you have a custom namespace exactly equal to the target namespace and associated to a custom prefix. In our case, it will almost always be Daniel PM 1982. And right down here you have the element form default attribute set as qualified, meaning that any XML instance that refers to this XSD document must use prefixes and namespaces when referring to any element or attribute or type defined at this document. So we've seen this already a lot, and what I want to show you here is the simple method declaration of elements. As we said, you declare the future root element as global here, access column element, name ship order. This is the future root element of the XML instances. It's not the root element here because the root element here is the schema at every XSD file. But at any instance of this document, the root element will be this element ship order here. And as we are using the simple method, any other element of this document or attribute or type will be declared nested inside the ship order element here. So you first open the ship order, then you start declaring all the complex elements with all the simple elements inside those complex elements. Here's another complex element also inside the future root element. Some more simple elements here, the attribute, and then you close the one and only global element, which will be the future root element of the XML instances. And lastly, you close the schema element tag. So this is the simple method, and you can see that as you declare all the elements at once, nested one to another, if you have 10 levels of nesting of elements inside that future root element, it can turn the code into a very chaotic view. So I really don't like this method, but you can use if you have a simple document or if you find any other reason to use it. But the worst thing here is that you can't reuse anything. You can't declare any other element or type globally or attribute in order to reuse these global elements and attributes multiple times. So it's not a good method to choose. And thankfully, we also have these other two methods, the divided method and the named types method. So here I show you the same document of the last example, but now using the divided method as its design. So you can see here that instead of declaring all the elements one inside another inside the root element itself, you declare all the simple elements globally, right, nested to the schema element, and as such you can reuse that elements by referring to them when you want to declare the elements inside any complex element. For example, here we are declaring the shape2 complex element, and we want to add as elements of that complex element some of the external elements we've already declared globally. For example, the name, address, email, city, state, country, and zip code. And we do not have to redeclare these elements because they are already declared globally here. We just refer to them using the attribute ref. Ref equals, in other quotes, the custom prefix, which means that we are using the components of this document itself, colon the name of the global element we've declared outside the complex element. So here we are referring the name, the address, the email, the city, the state already declared here outside, as well as the country and zip code. And at this other complex type called item, we are referring the title, quantity, and price elements, also declared here globally here. And finally, at the future root element, which is the ship order, we also refer to previously declared elements, but in this case to the complex ones as well as any other simple elements you want to refer. For example, client is a simple element here declared globally that we refer at the ship order future root element, but also shape2, which is a complex element with a lot of other simple elements nested inside it. The item complex element also with 3 other simple elements inside, as well as the discount ticket and date time, which are simple elements declared also globally. And here we also refer to a globally declared attribute, which is the order ID. You can see the order ID here. We declare the order ID globally, and we can reuse it at any element declaration. But in this case, we are only using it at the ship order attribute, always with the ref attribute for referring to external declared elements and attributes. We'll see all the details of the syntax later. Here I'm just showing you the design methods that are used to organize the declaration of components inside the XSD documents. But all the syntax details we'll see later at the next slide. And still regarding the declaration methods, we have the most, I believe the most used one, and the one I prefer, which is the named types method, in which the difference from the last one is that instead of global elements, we declare global types. Instead of referring to that global types with ref attributes, as they are not elements now, they are types, we refer to them using the type attribute, as here, but it's very similar to the divided method and as useful as it. So this is the same ship order XSD document, but now design or having its declaration organized following the named types method with the simple types declared here initially, then the complex types, for example shape2 type, with some elements nested to it, and at each element, in case these elements refer to external or globally declared types, we use the type attribute and the custom prefix to this document target namespace and the name of the type. Similar to what we've done with the divided method, but in this case using named types instead of named elements, and using the attribute type instead of the attribute refer. The rest is pretty similar. We declare all the complex types with the elements using the types already defined and reusing these types without having to redeclare all these types again and again. And here is the type that we'll set at the future root element, named as shape order type. And here we add all the elements with the respective types, reusing the types we've declared so far. And lastly, we declare the only global element, which is the future root element of the XML document instances, and set the type of this future root element as the shape order type with all other elements and types within it. So it's pretty useful for maintainability as well as for readability of your code, and actually a little bit similar to programming languages, as we've declared first the types, the simple ones, then the complex ones, and lastly the future element itself, using all the types defined previously. So that's it. You can choose any of these three methods for organizing your declarations within your XSD document.